All right, guys, good morning, and another YouTube video on the sheet that we're working on naming chemical compounds. Now, bless you. So, what we're doing so far in this class is we're focusing on ionic compounds, and that's what we're going to stick with for the rest of this week. Just ionic compounds. And I can't stress how important enough it is for you to learn how to name these things or look at a formula or look at a name and write the formula. So going back and forth, that's a big deal. Next, we're going to have a quiz on Friday on naming these things. And then next week, we'll talk a little bit about so-called covalent chemical compounds. Then we start learning how to write chemical equations and balancing chemical equations. And we'll take it from there. So, um, let's take a look at the sheet. I'm going to go through maybe 4 or 5 from each of the questions, and or three or well, some of them are smaller, so maybe like 2 or 3. But then again, I'll just turn the rest of the time over to you to finish up and to ask me questions if you have any questions. So, question number 1. Okay, once again, I've said this many times. Pay attention to the metals. Pay attention to the metals. Are they group 1, group 2, the main group metals, aluminum, magnesium, sodium, etc., or are they transition metals? Or are they those post-transition metals, lead, tin, and antimony, that might get more than one charge? So, some of them you should be really good with, and others, you're going to have to figure out the charges on them. So let's go through really quickly, and I'll do selected ones from question 1. Looking at the first one, it's very simple. It's LiCl. Lithium, don't forget, is an alkali metal. So make me proud. What charge do all group 1 metals get when they become ions? +1, right? So we never have to write in parentheses the charge because it's always going to be +1. Chlorine turns to chloride. Lithium, chloride. That's a real easy one. Let's take a look at some that might be a little bit more challenging. Like this is an interesting one. SnCl2. Now Sn is tin, and that's one of those ones that I said could have more than one charge. So if I have to write the name, I have to go ahead and I have to say, well, I have 2 chlorides. Each one's a -1, so that has to be a +2. So this would be tin 2 chloride. Tin 2 chloride for that. So I think you can kind of see the difference between main group metals and these ones that have more than one charge available to them. KMnO4. This is an interesting one. KMnO4. And this, if you looked it up in a chart, is an ion called permanganate. It's interesting because it has a metal as part of the polyatomic ion. So we would, and the K is potassium. So we would call this potassium permanganate. Potassium permanganate. That was letter R on the sheet. Is there anyone on that first section that you'd like to see? No, you're pretty good with them? All right, well, let's go ahead and instead of posting a video with all of the answers, what I'll do is I'll just post the answers online written out so you can have them. But just going through a few of these. How about we take a look at some from number 2. They give you a name, and you have to have the formula. So let's take a look at question A, sodium acetate. Well, if you were to have your chart of your polyatomic ions, first of all, Na is sodium, it's a +1, and then acetate is CH3COO. So that would be my formula for sodium acetate if you were to write that. And all you have to do, once again, look up in the chart, look at acetate, find its charge, make sure everything balances, and you're in good shape. Acetate can also be written like this, C2H3O2. If you wrote it like that, that's also correct. Let's take a look at some of these with the parentheses here. Okay. Alrighty, let's take a look, for example, at lead 2 nitrate. This is letter J. Well, lead, and it has 2 in parentheses, a Roman numeral 2, so that means the charge on that is plus 2. If you go to your chart of polyatomic ions, nitrate is NO3 with a -1 charge. So you're going to need 2 of these to meet up with that lead so that the charges cancel. So don't forget, when we're doing that, we have to put that in parentheses. Put a little 2 there. Now the parentheses is necessary because that nitrate sticks together as a group, and you want to indicate that we have 2 of those complete groups. All right. How about ammonium sulfate? That's letter E there. Ammonium sulfate's kind of nice because it has 2 polyatomic ions. Ammonium, which is a polyatomic cation, and sulfate, which is a polyatomic anion. Now this thing acts just like any other cation. Sodium, potassium, magnesium, whatever. So I just have to indicate, though, that I'm going to need 2 of these because that has a -2 charge. So NH4, parentheses, 2, SO4. There's your formula for ammonium sulfate. Let me see. What other ones do I want to look at? How about we take a look at manganese 2 hypochlorite? That's an interesting one. A lot of people get magnesium confused with manganese. So try to keep those 2 straight. Manganese can get a +2 charge. Manganese can get a +4 charge. So manganese is a transition metal. It comes right after chromium. So you have to be careful. And in the past, I've seen people get these confused. It's not hard to get them confused. Manganese and magnesium sound kind of similar. So hypochlorite, ClO, has a -1 charge on it. Again, if you don't have that memorized, don't worry about it. You have a table. And I'm also going to give you a printout table for your quiz. So everything you need to make your life easy, we're going to make sure we have. Periodic table, charts of the polyatomic ions. And eventually, you're just going to know these things. So, manganese 2 hypochlorite. Well, hypochlorite has a -1 charge. So, again, MnClO2. Easy peasy. Okay. Let's take a look at some from section 3. Section 3 is pretty straightforward, or question 3 rather. They're just asking you for some, they're giving you the name and they're asking for the formula, but they're using some transition metals there. For example, if you have iron 3 oxide, once again, if I have a +3 up here, and my oxide has a -2, you can either look for that least common multiple. 3 times 2 is 6. -2 times 3 is -6. Or you could just, for these oddball ones where I have a least common multiple, you can just bring the numbers down as subscripts. So I would call this Fe2O3. Nothing to it. Let's take a look at one that's a little bit trickier. Nickel 3 sulfate. It's actually not that tricky at all, but it has a polyatomic ion. Nickel, and once again, that Roman numeral 3 says, hey, nickel is in the +3 oxidation state, and it has a +3 charge on it. Sulfate, if you don't know by now, this is going to be one of the ones that you learn because we see it so often. Sulfate, nitrate, very common one. Well, again, let's do that little arrow thing, right? I need 2 nickels with a +3, and I need 3 sulfates. You getting them? Dylan, you getting them? Good. All right. So I'll leave some of those for you to work on if you haven't worked on them. So let's take a look at some of these ones in number 4, where they give you the formula for the so-called hydrates. And those hydrates, remember, had those waters attached. And I gave you that big list of all of the numerical prefixes like mono, di, tri, etc. So let's say we take a look at, I don't know, aluminum chloride hexahydrate. Well, aluminum, you have to go to your periodic table and you see that aluminum is a +3 charge and it's chloride. So I have to have AlCl3 and then it says hexahydrate. So you put the big dot there and Dylan, what's hexa? Yeah, yep, 6 waters, H2O, 6 hydrate. They're not too bad. And so, now, Cadence, did you watch the video with the hydrates yet or not? Okay, basically what we're doing is if you see ionic compounds and they say hydrates, those are organic compounds that within the crystalline structure of the ionic compound, there are waters stuck in. And in this case, there are 6 water molecules for every 1 aluminum chloride unit. And they're really interesting compounds because when you heat them, the water goes away. It drives the water off. And we're going to do an experiment where we change back and forth between a hydrate. We're going to actually use copper sulfate pentahydrate, copper 2 sulfate pentahydrate. And we're going to heat it up and drive the water off and then put it back in. I think you guys are going to like that. That probably will be coming up for you guys next week. It will be. All right, how about copper, well, iron 3, well, barium chloride dihydrate. That's one. Notice that there's no Roman numeral in barium because barium only gets a +2 charge. So you don't need that parentheses with a Roman numeral 2. BaCl2, barium chloride, and it's dihydrate. Christian, what is di? 2. Yep. 2H2O. Beautiful. Alrighty. And then let's go the other way. Let's take a look at some from number 5. I'll do B and C. Questions B and C. And you can see those. Now for B, you see this one. SnCl2 dot 2H2O. So it's going to be some sort of dihydrate. No biggie. Don't forget tin, Sn, Sb, Pb. Those 3 elements can get more than 1 charge. And so you have to say, well, I've got 2 chlorides, each one with a -1. So that has to be the +2 version of tin. So this would be tin 2 chloride dihydrate. Make sense, Wyatt? Okay. Carly, makes sense? All right. And here's one. Why don't you guys tell me what it's called? I'll write it up here. See if you can figure it out. What do you think, Wyatt? What's BA?
Barium hydroxide.
Yeah, barium hydroxide. You got it. All right, barium hydroxide octahydrate. So that's what I'm going to do for now. Oh, again, I always want to talk for like 5 minutes, and I'm going 14 minutes. So I'm going to stop this now, post it online, and you can work on the problems